Hey everyone, this is JT with the solution to my Banano infiltration puzzle. I hope you had fun trying to solve it, or just watching the video. Congratulations to the person who was able to solve it, as this one was harder and a little bit more tedious than some of the other puzzles. Great job sticking with it and claiming the prize. So as we watch this video, we notice that there are these patterns that start with one of these star beginnings, and then it kind of expands into what I'm calling these vines, green and yellow vines. So each one of these patterns starts with one of the starting stars and then expands with three vines and then has three ending stars, except for one, but we'll get to that later. But so anyway, these plants, three of them fill up each grid, and then they disappear, and then the next grid starts being filled up. So that happens 8 times in total for a total of 24 of these plants. That might seem to suggest that the solution is a 24-word mnemonic phrase, but that's not the case, and that's part of what made this a little bit tricky. It's very easy to go down an incorrect path there. So what is the actual way, though? If we notice these vines, the vines are in green and yellow, so there's only 2 colors there, and that suggests some sort of a binary code, and that's what we're looking for here. The solution to this is actually a private key that was converted from hexadecimal into binary, and then the binary is these vines in the correct order. But where really to start? I mean, this one was, there's a lot going on here. One thing that a few people picked up right away was that on, I believe it was the 5th iteration. Here we go. So here on the 5th I should call these the 5th infiltration of these Banano vines. This plant on the bottom right, let's see if I can stop it. This plant on the bottom right does not have an ending star here, so it only has 2 endings. So this one's blank, and that's kind of a big hint here. A couple people thought that may have been a mistake, but no, that's kind of probably the starting point. You see this, and you're like, oh, something's going on here. Maybe that's the start or the end. Well, this is actually the end, and the vines kind of grow out from the start. So I was hoping that it would kind of make sense that this was the end of the pattern. So this is actually the last, let's see, maybe 10 or 12 digits of a binary code. And in this case, green is 1, yellow is 0. If you solve this puzzle and do it the opposite way, you might have to check by just switching all those digits. Alright, so now that we know this is a binary code and that this is the end, the other key thing to notice about this puzzle is that each one of these plants has a starting point and 3 ending points. Well, exactly one of the ending points will match the starting point of another plant somewhere else in the puzzle. So you're going to have to look backwards, forwards. I don't think there's any on the exact same sequence of 3 on one frame, but there might be. So you have to look backwards, forwards, everywhere to figure out where some of those endpoints match a starting point. And you'll notice that exactly one endpoint will match a starting point, except for this plant right here that doesn't have an ending here. These other 2 do not match any of the starting points for any of the other plants, so that's another hint that this could be the end. So the way to do this is we kind of have to start in a plant and then follow the correct vine to an ending point, and then that ending point goes to the start of another one. Go there, find the correct endpoint, and then it's the binary code between that starting point and end point that is the solution. And we have to string all of those together, put them all together, and then convert that back into hexadecimal to get the private key. So I'll show you guys how I would go through solving this in an efficient way. Now you could just work backwards because we had that ending point, and let's go back to it. You could start with that ending point and then there we go. So we have the ending point here. Now we see the starting point, and so we now would need to find that starting star at the end of a different plant somewhere else in the puzzle, and then work backwards like that all the way through the puzzle. But hopefully I'll show you a little bit more efficient way that this can be done. So if we just start this from the very beginning, just going to start recording some data about these plants. So for me, I think the best way is to convert these starting point and end points into some kind of a data. So I'm just going to go through this and kind of give a number to each one of these. Now I'm coding orange as 1, this kind of teal blue color is a 0, and red as a 2. So for example, and then I start at the top and go counterclockwise. So for this, I'm going to convert to 1022. So I'm going to record that at the beginning, 1022. That's kind of the first starting point. Now you don't have to do the exact same scheme for identifying them, but it does help to convert them into some sort of form. All right, so the second one here is on the upper left. This, based on my scheme, will go to 2220. And then let's get the third. All right, this is going to be 2200. And if you notice, every single one of these is different except for when the starting points and end points match up. So there won't be, the only overlap are the crucial places where we need to follow the path. Okay, so once you go through the entire puzzle, write down all the starting points, you'd get something that looks like this. I separated out each pattern of 3 because they were on a kind of a different segment of the video. And now if we really want to know like which endpoints work, we're going to have to go back. So after writing down everything for the entire video for the starting points, we're now going to have to look at the endpoints and see which endpoint of each plant matches the starting point of another. So for example, this very first one on the bottom left, we see this star right here. I would encode this as 1, 2, 1, 0. So I'm going to look through all the starting points of the other plants and see if there's a 1, 2, 1, 0. And yes, there is right here. So there is a 1, 2, 1, 0, so that's the correct endpoint. So I'm just going to write here that this goes to 1, 2, 1, 0. So this is a start here, goes to 1, 2, 1, 0. Now I'm going to do the same thing for this next starting star, and this one goes to this one in the upper left. So 1, 0, 2, 1. We can find that as the starting point here, 1, 0, 2, 1. So I'd write that here. And then since we are trying to get the binary code for each of the correct vines, I'm also going to write down those. So for this first star, we go from starting at the starting point and then up left to this star. This is going to be 1, 0, 1, 0, 0, 1, 0, 0. So there's that piece of the binary code. The same thing for the second one. We're going to record that one. 1, 1, 0, 0, 1, 1, 1, 1. And again, if you did this opposite where you assumed yellow was 1, green was 0, at the end you'd have to just flip everything and try 2 different answers to see which one worked. Alright, so you'd go through the entire puzzle like that and end up with something like this, where you have all the bits of binary code on the right, all of the endpoints that are correct on the over here, and just as an example of one that doesn't work, if we took from this star in the upper left and we thought, well, what if we went down to this star ending point here? Let's see where that one is. Well, this would be coded as 1, 0, 1, 0. And if you notice, there are no 1, 0, 1, 0 codes on this list here, which means that none of the plants start with that pattern, essentially. So you'd be like, oh, that's a dead end. That's not the correct vine to follow. So that's kind of what you had to do. And then for getting the full binary code, now we have to work backwards. So starting at this endpoint, let me pull that up again. Here, there it is. So the pattern 0, 0, 0, 1 to end, well, again, this 0, 0, 0, 1 is the starting point of this last plant. And then we go up towards the portion that has no end, and we'll see that that's the binary code here, 1, 0, 1, 0, 1, 1, etc. That matches this last vine here. So we can copy and paste this. I put that here at the bottom, and then we have to work backwards. Now we have to look at where this 0, 0, 0, 1 shows up as an endpoint. So that would be this part on the left as a start. Now we need to find where it is an endpoint. And that is up here. So here we have one where 0, 0, 0, 1 is the endpoint. So I would copy this piece of the binary code and put it above that last bit here. So there's the second piece. And then just based on how I recorded this data, I would know that, oh, well, now I have to look for 2021. That's the one before it, so now I have to figure out where 2021 is the ending point. I would go down, here it is, 2021 is the ending point. Here's a piece of binary code. Copy and paste that here. So after you go kind of backwards through that entire iteration, you get this, concatenate it into this binary version of the private key. This should be 256 digits. So if we take that, we copy it, and we put it in a binary to hexadecimal converter, we get this hexadecimal number, which is the private key. You have to be a little bit careful with this one, because notice how this starts with an 8 when you convert it. Well, the first 4 digits of the binary number are 0, 0, 0, 0, which converts to a 0, and this calculator drops that initial 0. So the full private key starts with a 0, and then is exactly what this converter is showing us. And if you count the number of digits here, you only get 63. If you count the number of digits in this binary private key, you'll get 256. And one possible way to potentially see that that was a solution was, well, if you knew the private key would be 256 bits in binary, and you kind of count the length of these vines, you'd be like, oh, well, maybe there's like an average like 8 or 9 per vine, and there's 24 of them. Multiply that, you're close to 256. So maybe the average is more like 10 or 11, something like that. But you're kind of in that right ballpark, but it's still confusing for people who have never seen this as a private key. So this was a more difficult puzzle. So nice job to whoever was able to solve it fairly quickly. I thought it might go unsolved longer a week, but congratulations again, and good luck on solving the other puzzles. You just take this private key and you can import it into something like My Ether Wallet, access the wallet, and take the prize.